Alrighty, boys and girls, welcome to the beginning of Chapter 7, Geometry. Good stuff. So we're going to start out with Chapter 7, Section 1, Classifying Angles. Okay, so the first thing we need to get out of the way is the definition of an angle. Okay, an angle, it's two rays that share a common endpoint. Let's take a look at what one looks like. There's one, and there's another. Now, where they meet, that's the endpoint. And we actually have another name for that endpoint in an angle. It's a special name. It's called a vertex. Vertex is where the two rays meet. Now that we know what an angle is, let's take a look at the ways we can name an angle. Best way to show you that is with an example. Now there's 4 different ways we can name an angle. The first way, A, B, C. Angle ABC. Second way is going to be the exact opposite order. Angle CBA. Notice that in both of these ways, the vertex is in the center. You can't just say, for example, CAB or ACB. Has to go in order. End, middle, end, end, middle, end. Vertex always in the center. Next, we can actually name it by the vertex, angle B, and we can also name it by the angle, if the angle is named inside, angle 5. Now let's learn how to classify angles as acute, right, obtuse, or straight. So I'm going to show you the 4 ways that you can classify an angle, and I'm going to give you a really stupid way to remember these. Pay attention, you'll enjoy it. The first classification we have is acute. The acute angle is more than 0, but less than 90. It's the smallest angle that we're going to look at. And think about small things in life. Let's think about a small baby. Whenever you see a baby, first thing people say is, oh look, that's acute baby. See what I did there? Acute baby, acute, small angle, acute baby. Get it? Alright, let's take a look at another one. Okay, let's imagine the acute baby got a little bit older and started to stand up. In fact, started to stand upright. And here we have a right angle. Right angle is 90 degrees. Also, if you don't see something telling you how many degrees an angle is and you can't tell if it's acute or obtuse, a right angle usually has this symbol. That little box right by the vertex, that lets you know the angle is 90 degrees. So, we had acute baby, an acute angle, started to grow up, stood up right, had a right angle, 90 degrees. Now, let's imagine this baby, once it stood up right, didn't really do what it was supposed to, and went straight for the cookie jar, and kept eating and eating and eating. This baby kept eating and eating and eating until it didn't become chubby, didn't become fat, it actually became obese. And the name of this angle is obtuse. An obtuse angle is more than 90 degrees, but less than 180. So the baby continued to eat and eat and eat and eat and eat. And then finally, the baby got really tired and laid down, nice and straight, and went to bed. And here we have a straight angle. Straight angle is exactly 180 degrees. And here's the baby, dead, asleep. So again, acute angle, more than 0, less than 90. Think of acute baby. A right angle, 90 degrees, baby stands upright. Obtuse baby, more than 90, less than 180. Think obese, looks like it has a big belly there. Straight angle, 180 degrees, dead, asleep. Next, let's talk about vertical angles. Vertical angles are opposite angles formed by the intersection of 2 lines. For example, these 2 lines intersecting form angles. Angles 1 and 2 are vertical angles. They're opposite and they're made by 2 intersecting lines. Angles A and B are also vertical angles. They're opposite and formed by 2 intersecting lines. Now, what makes vertical angles so special and why we care is because vertical angles are congruent. When angles are congruent, it means they have the same measure. Think of it like the measures are equal. So, angle A is congruent to angle B, and angle 1 is congruent to angle 2. Next up, adjacent angles. So, two angles are considered adjacent angles if they share a common vertex, share a common side, and do not overlap. Now, you might be thinking, that sounds really hard to imagine, but I'll show you with the picture. Here, angles 1 and 2 are adjacent. They share a common vertex, they share a common side, and they do not overlap. In this picture, angles 1 and 2 are adjacent, angles 2 and 3 are adjacent, 3 and 4 are adjacent, 4 and 5 are adjacent, 5 and 1 are adjacent. Angles 1 and 3 are not adjacent. See the difference? Also, while we're looking at this picture, angles 1 and 4 are vertical because they're formed by two lines intersecting and they're opposite. Angles 2 and 5 and 3 and 5 are not vertical, just angles 1 and 4 in this picture. Now, let's look at two problems that you're very likely to see on a test, very common problems to this section. First, we'll start with vertical angles, and we'll try to find the value of x. Now here you can see that angles A and B are vertical angles, and that means that they're congruent. But what if instead of having A and B, what if we had some values in there instead? For example, if B was 130 degrees, then I know that A would also have to equal 130 degrees. But instead of A, what if I had this? 2x plus 2 degrees. This is an example of a problem that you're very likely to see on a test, in homework, on a state exam. You know that because these two angles are vertical, they're congruent, therefore 130 degrees equals 2x plus 2 degrees. Now let's take a look at how to solve this. Because this is true, and this problem we solve just like we learned in Chapter 6. Now, keep in mind, this angle is 130 degrees, but x is 64, not the angle, just x. Let's take a look at one that involves adjacent angles. Now, remember, a straight line, just like the dead, asleep baby, represents 180 degrees. So if I chop this straight line into two pieces, this angle and this angle, I know that angle A plus angle B have to add up to 180 degrees. If instead of A and B, I have written, for example, 120 degrees and 2x degrees, my equation would change from A plus B equals 180 degrees to 120 degrees plus 2x degrees equals 180 degrees. If you need to pause the video to look at the substitution and have this make sense to you, go ahead and pause it. Take as long as you need. Now, because this is true, so let's solve for x. And there you have it, x equals 30. Now remember, this angle does not equal 30 degrees, x equals 30 degrees. To find this angle, simply substitute 30 in for x, 2 times 30